Hello everyone, this is Ruchik Divakaran from A3R3 Quandary and welcome to another episode of In and Beyond with A3R3 Quandary. I hope you all are doing great wherever you are across the globe. So first of all, thank you all for your overwhelming responses on our first episode. I know that it was our first attempt towards something like this and we really appreciate for your honest reviews and responses. Thank you so much for that. So here we are with another episode of In and Beyond, and we have our in-house geeks, Madhusudan Srinivas and Amir Hussain. And along with them, I have another guest with me, Atul Kumar, who is again our in-house musician and vocalist for A3R3 Soundsphere. So welcome, Amir. And
Hey, Ruchik.
welcome Atul. Hope you all are doing good.
Hello. Yes.
All
Hey,
right.
guys.
Great, wonderful. So let's start with Atul. Atul, bro, how are you feeling? How are you feeling? Like what did you think about our first episode?
I think it was very, very nice video. I think these are the times where people actually are getting time to learn something new, and a lot of people are spending so much time on online. So, idea was to make that time useful. So I think we are doing that already. So it's a good start for us too.
Right. Well, thank you so much. And you're right. Like it was our first attempt, and somehow we got really good responses and reviews as well. And people are. I was actually surprised. Like people like these kind of stuff, and our attempt for something like this didn't didn't go in vain, I would say. And people are really liking it. People actually reached out to us with their opinions and their insights about the black hole, which was our first episode about was all about, and it actually went out really well. What I can say, I can just thank them again and again. That's only what I can do right now. Thank you, Atul, for joining us today, and it's really great to have you here with us.
Me
Madhu,
too.
good evening, and how are you?
Hello, Mr. Pillai. Doing well. Very well. Thank you. How are you?
I'm good, thank you so much for asking. So, did you like the first episode, and did you see all the responses?
Oh, yeah. Thankfully, it's not as scary as I had imagined in my head. So, yeah, everything little better. So, yeah.
But as I said, we all are in the learning curve of something which we have never done. So this is actually a good thing for us. We at least attempted something, and people are giving us honest feedbacks, and they are giving us good reviews as well as they are appreciating our work. So this is something which I wouldn't say no one has done, but I would say which is not commonly done in India. So it's a good attempt for all of us, and there are several I could say several people out there who are actually like me, who don't know anything about these things or who know very little about these things, and there are again very so many people like you and Ahmed, so that you can explain it to me or people like me, like what exactly is let's say black hole or in that say per se, whatever we talk about the universe or anything in beyond what we see. So it's really good. I mean, well, I would thank you all for joining us again and again, and I would like to thank you everyone for these responses. And please let the responses keep coming. I mean, we would like your opinion more and more so that we can improve it much better by the episodes as we go further. Well, thank you, Madhu, for joining us today. And Amir, good evening. How are you?
I'm good. I'm good. How are you guys?
I am doing good. Thank you.
Yeah.
So, what is your say about all the hype and whatever the responses what we got and the review what we got about our first episode?
Yeah. I never thought we'd get so many responses because I've never seen any one of us talking about all of this, and then I thought that until you start a conversation about all these things, until then you won't realize that how crazy all this is, like these conversations that we are having.
I agree.
Yeah, people are surprised to listen to so many facts, literal facts that we actually say, and then it's fascinating to listen to responses basically from other people.
Right, right, you're right.
I'm surprised, there are these many people reaching out.
Yeah, yeah.
So
I
there
was actually
definitely
surprised
is
one day
appetite for this.
after the video was launched, and the next day I got like several set of messages saying, like, it was really good, and you should actually add more about black holes. Black holes are not just about the singularity and not just about the thing. That's the reason we told everyone, like, since it was our first episode and we had limitation of we had time foundation, so we were bonded with a very limited set of time. We were not able to talk much about it, and that's why in the end of the episode of episode 1 we actually told everyone that we will be coming up with a second episode with all about black holes as a part 2 of black hole. So here we are, and let's begin the show. What say?
Yeah,
All right,
sure.
ladies and
Already.
gentlemen, welcome to A3R3 Quandary In and Beyond once again, and this is our episode 2 of In and Beyond, and this will be everything about black holes part 2. All right, so Amir, Madhu,
Yeah.
so Atul is new since he wasn't there last week. So you guys were always there, and you guys are the in-house geeks, and this is what we spoke about last week. So let's start from where we stopped. So for the people, to our viewers, let me tell you that this is our second episode regarding black holes. So this is black hole part. All right. So, Madhu, I would like to ask you about, are there any kinds of black holes?
Yeah, very good question. You can. There are many aspects or features to a black hole. One being the spin, if a black hole first of all is spinning or not. There are a few that are just still with the accretion disk around them just going, and there are some which spin in the opposite direction of the accretion disk spin.
Okay.
And there are very elusive black holes that are just sitting quietly there without spinning at all. And there are other aspects like the temperature of a black hole, due to which, roughly translating, you would say the color of a black hole. So the smaller the black hole, the more hotter it would be. Okay. And then there would be the charge for a black hole.
Sorry, cut you off, Madhu. Could you please tell that again? Smaller the black holes?
Yeah. So the thing is, the temperature depends of a black hole, whether it's extremely hot or cold, depends on the size of a black hole. If it's so these are the various aspects like the spin, temperature, and charge, and then you can classify them according to their size. That's mostly the classification used to classify black holes. The supermassive black holes, which are at the galactic centers, and then the intermediate black holes, which are not as big but are pretty huge. And then there are the standard stellar black holes, which come out of stars dying, and any star which is around 20 solar masses, so 20 times the size of the sun, they would only then will it become a black hole, and such ones are the smallest of the ones. Called the stellar black holes. Now, each of them have temperature associated with them, right? So the bigger the black hole, you wouldn't be able to see if it's hot or cold, unless you were pretty close to it. And the intermediate is slightly hotter. You do start seeing the readings there. And the stellar black holes are the really wild ones, which are extremely hot. So the temperature of a black hole depends on the size, the classification of the black hole. So yeah, roughly speaking, you categorize them based on their sizes: stellar, intermediate, and stellar, which are roughly around the solar masses 20, 30, 40, 50, 100. And then would be the intermediate black holes, which are thousands of solar masses, thousands of times bigger than our sun, massive than our sun. And the ones at the galactic centers, the supermassive black holes, they would be in the order of millions and even billions of solar masses. So this is an entirely huge topic on its own. How we get these black holes and all. So yeah.
And Madhu, I have also read somewhere that the smaller the black hole, the more aggressive it will be. Is it true? Like, I'm not sure where I read it, but I just had doubt. Like,
no, true to a large sense, because when a star collapses, it becomes it crashes in on itself, and then explodes all the outer layers, and just the remaining core sinks into itself by virtue of its own gravitational pull, and collapses into a black hole. So what happens in these solar mass stellar black holes is it's pretty recent compared to the other two types. So when it's pretty recent, it has more material around it. So as the black hole spins and the mass gets ejected out of it, it does quite around 40% of the mass never gets into the black hole again. But the remaining 60%, that's in the vicinity of the black hole. So it's held in together by the tidal forces of this black hole. So while this black hole spins, it is also warping and spinning, yanking at the very fabric of space-time. So it already has a spin, because stars do spin, and then the space-time is also spinning, and there is so much matter around it. So all of this coming into the accretion disk, they have their own angular momentum, which adds to the stellar black hole's own spin. So it kind of helps it spin more quickly or rapidly than the other two. Because supermassive black holes, they have been at galactic centers for quite a few billion years. Like our own galaxy came into existence about roughly 10 billion years ago. So that supermassive black hole, Sagittarius A star, at the center of ours, it has devoured or eaten anything and everything that has come into its path. So there is huge void between it and the next body, which is the stars. So there is not enough matter to attribute more angular momentum to this spin. So it's just calmly sitting there, spinning at a lower rate. And same with intermediate. Intermediate are very elusive, because the most common ones that we see are the stellar black holes that come out of stars and supermassive black holes. But intermediate black holes are the ones which have had enough to eat in their path, like other stars in their vicinity or other black holes, and they become slightly bigger. So yeah, lost my.
And also, I think I saw news from the scientific community, like I think 1 or 2 months back, that our black hole was like rather more active than it was before. Like for that some period, I think it was ours black hole itself. I mean Sagittarius A star.
Yeah, right.
It did creep me out, but then I realized that our galaxy is very huge, man, for it to affect us right now. And we are at the edge of the galaxy, right? So then I thought about this, and then I was like, okay, now I can sleep in peace, basically. Black holes won't come and destroy us.
Yeah, so
I sent you one link. I mean, a few days ago when we were actually talking about the second episode of our podcast, if you remember that link, in that link, it said, I have the link with me right now. It said that 2 black holes collided in the deep space and produced a burst of light for the first time. Did you remember about that? So it was, it was termed as, they were claiming that astronomers have apparently seen the invisible. So, why was that about? I mean, I actually read that article again and again, and believe me, I couldn't understand the part. Can two black holes collide?
Oh, yes.
Yeah, yeah.
So
So,
when they collide, what will they become like?
So, like any heavenly body, if two of them cross each other's paths, one gets annihilated, or if both are of similar masses, both of them get affected. So the same thing with even these black holes. So the thing is, because they are warping space-time around them, and all the matter is all completely charged to astronomical limits, you can't put a scale on them, and when you see the numbers it does not make sense to you because it's uh, bigger than any explosions that you see out in space. Let's see the supernova explosions. So that is because of the matter in the accretion disks coming along with the black holes, while the black holes kind of melt and fuse together. So those charged particles clashing together, they give out this extremely bright light, and also a lot of energy is given out by the black hole merger itself. So to just put this into perspective, how wild and powerful and cataclysmic these are, when this was observed, the total energy that came out of that light, out of that merger, it was more than the energy given out by every star in the entire known universe. There are
That's
trillions of
huge,
galaxies.
man.
There are trillions of galaxies in the known universe, and each of those galaxies have between billions to trillions of stars again. So the light that has been coming out all the time through entire space is nothing compared to just these two black holes colliding. The light that this thing produces. So just to give you a perspective, so they are damn powerful. Yeah.
So, after watching the last video, I had this question in my mind. Just wanted to know what was the kind of the black hole which we saw the last time. I think there were some pictures out some months back, and it was trending all over, and we did show in our video. So, since we were discussing the types of black holes, probably
Brilliant.
someone can explain that. Yeah.
Hey, good one. So yeah, that was I think it came out in April or May last year.
Right.
So that was the black hole that was photographed by the EST team, led by Dole Shepman, the director of the Event Horizon Telescope project, who put together this project to photograph a black hole. So yeah, they were looking at the supermassive black hole at the center of this galaxy called the Messier 87. So this was a supermassive black hole at the center of M87. So yeah.
Okay. Okay.
So that was
And also, Madhu, do you remember when the gravitational waves were discovered? I mean, they were sensed by the LIGO detector. We were in office together, right?
Oh my God.
But that was not black holes. Those were two neutron stars that collided. Right?
No. Actually, the first ever detection was of black holes. In fact,
Yeah.
they have so far detected 10 collisions. Most of them are black hole types, both black holes, and two of them were neutron stars colliding, two incidences. And I don't think
we
have
were imagining.
any
We were imagining
we had black
ourselves.
hole and a neutron star colliding. I don't think we have seen that, but yeah.
And you remember we were going crazy thinking about these when these black holes collided. We were actually getting stretched. Basically, the whole Earth got stretched.
I'm really sorry to cut you off here. Guys, you have to talk in English, and the language which I understand. Believe me, whatever you said, I didn't understand anything. So could you please explain me what you were talking about?
That was the craziest detection ever, Ruchik. I think it's better if Madhu explains it. Please, Madhu, carry on.
Please.
So yeah, there was this. That was an experiment aimed at detecting gravitational waves. once again, it was an offshoot or a product of Einstein's theory of general relativity, right? So out of them came this concept of black holes and gravitational waves, which other scientists then came up with the ideas with, and they mathematically proved they were actually possible. Such things might exist. So we saw about the EHT, the Event Horizon Telescope project, to take a photograph of a black hole. So that was one, and the other one was the gravitational wave detection done at the US. They built two facilities, two very similar facilities, one on the west coast and one on the east coast of the US, so that if there is any mismatch in the readings, they can rule that it's not a detection. So they built. I'm not getting the word, but yeah, they just wanted to be sure. So yeah. LIGO was the name of this experiment. Laser interferometer gravitational wave observatory, right? And this observatory has two arms. It's in the shape of an L. Okay, so and each arm is almost 4 kilometers long.
4 kilometers,
4
yeah.
kilometers long this way, 4 kilometers long this way, and right at where both those arms converge, here there was the observatory, right? So what they were doing was they were shooting lasers at that point. So yeah, they were shooting lasers at that point, and the lasers.
I think we can show a picture now, like LIGO.
Oh yeah, that would be better.
Viewers will understand.
Exactly, that would be much more better because I mean, oh yeah, I just saw the image. Oh my God, this is insane.
It's fascinating.
This was for detecting the gravitational waves, which was only in theory until 2015. 2015, September 10th or 14th, I guess, yeah. That is when they came out with the data. They had captured this information in 2014, and they were going back on it just to cross-check that this was not an error in the observation that they made. So every experiment, every breakthrough that reaches us has been verified, trying to be tested and challenged by the scientific community for at least a year. So once everyone agrees the measurements were what they were actually implying to, then it gets released to the public. So gravitational waves is, like we said last time, space-time. That's the medium of the universe, the fabric, if you may call it, the fabric of the universe. So you drop in a dense object, it makes a curve in space-time. Otherwise, it will be flat or curve. So when two of these black holes, massive bodies like black holes or neutron stars, which are the next bigger thing, massive things, when they come together, you can imagine just one black hole is enough to make life hell for, if there is any life on planets close to the black hole, it'll be hell for them, right? Almost obliterated. Now, two of these black holes, yeah, coming together and circling each other close to the speeds of light, right? 3 lakh kilometers per second. Two such huge bodies revolving very close to that speed. And once they, so when this is, they are sending ripples in space-time or in all directions. Okay. And what happens is anything that is in the path of those waves, it is simply sitting there in that space-time, right? So when space-time is stretching and becoming shortening, even the body sitting in the space just stretch and become smaller.
Okay.
But this won't be noticeable to us because the gravitational wave that we saw, the amount of stretching that happened was at proton levels. Some percentage of proton diameter is what the stretching was at. So all of us became bigger by just that much and became smaller again by just that much. So,
and we were able to detect it. Imagine, like
we were able to detect that
What
it's like
makes what makes me go
this
crazy is
magic exists.
we still have flat earthers, bro. Even after scientists are working on this like so crazily, I don't
Yeah,
understand that.
that's
The
another
logic.
strange phenomenon that's going on.
Yeah.
Sometimes it is
And
hard for me.
imagine, Ruchik, just imagine, okay. Now, when Einstein was still theorizing all this, okay, Einstein and his fellow mates, okay, they were still theorizing this. They were just theorizing this, okay. At that time, we still had that ripple coming at us, basically, to be detected by us. So imagine if Einstein was here now, and basically it's like we are still doing homework on Einstein's problems,
Exactly.
basically. Correct,
In the
right?
also we
Like
spoke about.
every single, even the gravitational lensing, the gravity waves, and all the other phenomenon that is like that he theorized long back. It's
Exactly.
we are still trying to prove it, and it's being proven all the time. So you can understand how his mind worked, basically. It was I. It's still hard to contemplate like how his mind worked.
I
I don't know.
agree.
Maybe he was an alien or something.
So
Aliens.
just
Maybe
to
he time traveled.
probably you never
Maybe.
know.
Maybe.
So just to lay it out for you.
An
So
alien.
this event that was detected by LIGO, the gravitational waves, that was at a distance of 1.3 billion light years away. Okay, that is where the collision happened. Now light, which basically translates to, it takes light 1.3 billion years for it to reach us. So
Right.
when that event occurred, life had just started on Earth. Okay,
Yeah. Even that.
multicellular.
That's
There were
crazy.
single-celled organisms. There was multicellular organisms had just taken form on Earth.
Exactly.
We did not even have uh, animals
People.
like us to think about this,
So
right?
what we
And
actually
then,
detected was something which happened billions of years ago.
yeah, yeah, and then it came about 100,000 light years away. That is when it had reached the edge of the uh, our
Solar
galaxy,
system. Okay,
Sagittarius
galaxy.
system. Okay, because our galaxy is 100,000 light years from one end to the other. So it had just reached, and at that point, I think Homo sapiens, as the current form, we were not there yet, I guess. Okay, and still it still continued traveling inward, and uh, there is one more bit in there. So the first time when radio waves were sent outside Earth was during World War II, when Hitler wanted to ensure that he was heard all across the country and the planet.
I think
So they were
this was
announcing.
during the Olympics, right?
Yeah, yeah. The Olympics also
Yeah,
happened.
yeah,
Yeah,
yeah.
Munich. Sorry, not Munich. Yeah. So when that happened, it was still on the farther edges of our solar system. This was around 1944, 1945, and then by the time it entered our solar system and reached Earth, humans had evolved from this multicellular organisms to this complex beings that we are, and had the potential to wonder about these things, right? We had just started to wonder about these things, and in such a short span, like modern science is roughly speaking 400 years old. That is
Right.
when Galileo first
Galileo, yeah.
turned
Right.
his telescopes, invented the telescopes. So to just see how fast the scientific approach or the technology has bettered, it just took 400 years, and we have been around for such a long time. So it's fascinating. So that had to wait for humanity to take form and be able to come up with intelligence enough to think about these things, and then finally see it. So it is so beautiful when you think of it at such scales.
It gives you perspective, too. Like
Yeah.
seriously.
Yeah.
So once again, to reiterate what you earlier said, so the types of black holes, could you please reiterate once again so that we can go to our next section?
Yeah. So those are the depending upon the sizes, the black holes are the stellar black holes, which come out of dying stars, anything more than 20 solar masses, stellar black holes. And next are the intermediate intermediate black holes, which are between 1,000 to million times the mass of our sun. And then you have the supermassive black hole right at the galactic centers, which are on orders of millions to billions of solar masses. So, we understand how the stellar black holes come into being and how the intermediate black holes come into being. Intermediate black holes come into being when multiple black holes fuse over a course of time, fuse to become bigger. But how do these supermassive black holes at the galactic centers form? We do not have an idea about it yet. We are all still trying to find out how they came into existence, because 14 billion years, roughly speaking, that's the age of the universe. That is not enough time, even though it's so much for us. For a black hole going from stellar to becoming the supermassive black hole, 14 billion years is not enough. And it also means if there is roughly a billion stars in the galaxy, this black hole will have had to consume 1 out of every 5 stars in that galaxy.
Whoa.
So there is no way that so many stars can fall into it, because it's all spread over huge distances. And there's not enough time, even if so many do drift into the black hole's course. So this is a big mystery. There are various theories coming, trying to solve or answer this, right? So some say, some theories suggest that it may be the dark matter, which is the major type of matter available in the universe, that may be responsible for creating these supermassive black holes. Because you don't know what happens past the event horizon. I mean, we know a bit from what happens between the event horizon until the singularity. There are ideas, there are theories, but into the once we get into the singularity, we have no idea what's exactly happening, right? So one theory is that the dark matter, which is 5 times in abundance of the regular matter that we see everywhere, that because we have not been able to detect it, no forms of experiments or observations are giving us any clue as to what they are. We can see, we can only detect them by virtue of the gravitational field that they affect on other regular matter, like other stars or galaxies. So somehow they are trying to see if.
And I think the problem is they don't even interact with each other. I mean, these particles, they don't even interact with. Yeah.
So there is black matter raining on us right now. We have no clue, but it is there. It is here. So that is one take. And once you go past this singularity,
who knows what all we could come to know once we know what dark matter and dark energy is, basically. Maybe we'll have a sustainable means of energy and everything. I don't know.
You never know. Yeah.
All right. So let me ask you guys this thing. I read it somewhere. We read about and we knew. I mean, now we know about black holes as you told us. Now, what is white hole? What is a white hole?
So these.
I mean, there's something called white hole, right? I mean, it's not just like a white hole and a black hole.
It's here, right?
You know what I mean?
I never knew there was a white hole until now.
The simplest explanation that I think even we can explain is like it's exactly opposite to a black hole.
We are right now.
I didn't get you.
So at what we are right now,
We know black holes, right? Black holes tend to consume all the matter and everything around it, right?
Right.
So exactly opposite of a black hole is a white hole. Is
will
what scientists,
will
not
it
science.
will it produce matter?
It's at the other end of the black hole. Basically, everything black hole takes out. I mean, takes in. There's a funnel type of thing. Imagine a funnel type of thing. Okay, that's a Einstein Rosen bridge. And then at the end of it, all everything that is consumed by black hole is let out by a white hole, basically.
Wait, one second. Okay, now you are
So
actually
it's just a theory. I mean, it's just a hypothesis. It's not even a theory, I guess.
maybe it's a
No?
hypothesis, but the thing is, you are now consuming my brain. Please. So
I mean,
let's start with okay. I went into a black hole. All right.
okay.
I went into a black hole. Now you are saying that there's a funnel thing. So let's say it's a funnel. So again, it's a hypothesis. Let me tell you guys that this is we don't have any proof of it, but yeah, there is hypothesis and theory about all these things. So I'm just asking about more about these hypotheses, what exists uh, on the other side of the black hole. So let's say this is a black hole. It's a curvature and it's a funnel kind of thing. So what you're saying is that funnel thingy, the what do you say
The path.
the path the path after the funnel, it actually opens up to a different universe, you're saying? So is that known as a white?
Maybe some scientists even think that at the other end of the black hole is the Big Bang. I mean, Big Bang happens like multiple times. Even that is one theory, and there are so many. There is a holographic theory, and that is crazy. I think that will
I'm
take
liking
one
the
more.
expressions on Atul's face.
I swear, everything is new to me. I'm still watching.
Exactly.
So now imagine. See.
Like,
Let me try. Let me try to. I don't know, like if even I understand it properly. Okay, but just imagine. Okay, we know like we know about Big Bang, correct?
Right.
We are able to like the large hadron collider. We know even after like the even after 1 nanosecond of the Big Bang, what happened, we know what kind of particles we came in, we got, even that we know. Okay, but no one knows what happened right at the time of Big Bang, what caused the Big Bang, right?
Right.
So what some scientists think, like everything that goes into the black hole, it becomes a different universe at the other side of the black hole. So basically, that singularity at the end of the black hole is a means for a different universe, where it spews out all the matter taken from this universe and creates a different universe. Even
So
that is a theory.
so basically, we are in a black hole, you're saying?
No, not we are not in a black hole exactly, but all the black holes we see, like every single black hole is able to spew out a single universe.
So, before we get to the point, let's take this one step at a time, okay? So,
Okay.
white holes. You asked what white hole is.
White holes.
So,
Okay, thank you.
so black holes also, we had no clue that such things existed, and we had no clue that even Neptune and Pluto existed until the
Yeah.
19th century. So black holes was a different thing. But black holes idea came from the general theory of general relativity of Einstein's. So,
Again, Einstein. Man,
again,
Einstein.
so there were parts of the theory which could give rise to such massive bodies, which warps space-time around it. If it's massive and dense enough, it can warp space-time around it, right? So this is a black hole, and we have discussed this at length in our previous podcast. Now, the same theories and the calculations also say or also give a clue to the existence of a very same body, but in the reverse manner, wherein this black hole is bending space-time and sucking everything that gets too close to it, and that matter is never getting out, right? So you would never know what's happening to all that matter. Now, at the other end is a white hole, which is just a point in space-time through which stuff just keeps coming out. Even if you did try, even light cannot, if you had to, imagine this. If you had to stand close to a white hole and try to shine a light, right? That light won't reach the white hole because the very uh, space-time is being pushed out of it. So when space-time is coming out like this, you try to shine a light through its path, it won't work. It either just stops there, the light just sits there, or it also takes the path of space-time. So this is the point in space-time into which nothing can get. And a black hole is a point in space-time in out of which nothing can get, right? So completely reverse. And these white holes are also there is mathematical evidence for the existence of such a body. Now, so the idea is that at the end of every black hole is a white hole, and both are connected together through a funnel-like structure through which matter travels from the singularity in the black hole to the white hole. Now, this funnel is called the Einstein-Rosen bridge, right? So this is the warping of space and time. It's not like you throw our phone into it and it will just move through and come out out of the white hole. It'll all get broken down into pieces, a different thing. But this is a condition in space-time where nothing makes sense, but it's somehow able to just transfer everything from the black hole through it and ejecting out at the white hole. So this gave rise to new ideas, because a white hole is also very close to what a singularity, like how a singularity behaves, but just in the reverse order. Everything keeps coming out of it. Even if you did try to put something in, there is no way, because space-time is pushing on you, outward on you like this. So the idea is this may be the singularity that caused the Big Bang of our universe. So all this matter that came out of the Big Bang came out of a different black hole. All the matter that it sucked traveled through the Einstein-Rosen bridge, or a wormhole. Speaking in layman terms, through the wormhole reached the.
That's a wormhole.
That's a wormhole, yeah. Which.
Thank you for clearing interstellar for me.
So that's the shortest path on space-time. Like, if this is space-time, this is point A and this is point B. If you have to travel, you just need to take the path of the space-time. Now, however, a really old newspaper, don't judge me, but a dirty one as well. So, point A to point B. Now, imagine that this newspaper was a kilometer long. So it's a really long distance for, say, an ant, putting it into this size. But however, if you had to just close it over, now this point is B and this is A. So the ant simply has to go from here, to here. And the shortest path is punch a hole through space-time. So make a hole here, make a hole here, and from A to B, just like that, instead of it traveling and consuming all the time to reach point B. So that's the idea of a wormhole. So this is what gave rise to the idea that at the center of every black hole is a tunnel through which all the matter that gets sucked into the black hole travels to another part of the universe and gets ejected out, and there forms another local universe, if you may call it. So
this is how Thor travels in all Marvel movies.
Oh yeah.
To the Bifrost. through the
Yeah.
Bifrost, basically.
Oh, right. So basically,
that's a wormhole.
Oh,
so if you want to travel to another universe,
you
are we
just
Not another universe,
back?
another point in
Another part.
space.
Okay, another point in the universe. Okay, okay.
so you just
So
need
instead of traveling for so long, you could just create a wormhole and just end up on the other side
Yeah,
from
just create it, just like this.
just like this.
so again hypothesis, guys. Again, wild.
Bifrost is a wormhole. If you want
Okay.
to understand,
Now you get it for me. So I have this theory now. What if in the future, since we cannot travel in the speed of light, as you explained last time, we cannot travel in the speed of light. And even if we travel at the speed of light, we will not be able to reach anywhere to see whether there is a life or not. So if we create something like the Bifrost, if we create a if the scientists, if our great scientists actually come up in the future with a concept of having a wormhole right next to us or something, I mean they can generate one, so we can actually travel to a different part of the space.
yeah, we'll do one thing, Ruchik. We'll give you a walkie-talkie and send you into a black hole. See if you can come at the other side of it.
But
Then it will be proved.
like like I'll be standing there, and every electron of my body will be like sucked in. So I don't
Maybe
think.
it gets rearranged on the other side of it. You never know.
Yeah, yeah.
But someone has to try.
That's an idea of
Yeah,
teleporting.
that's how you make an alien, right?
Yeah. So the idea of teleporting is not and a body enters and the entire body travels through that medium and appears at the other end. The thing is, this body that is entering is broken down to its fundamental pieces, atoms, right? So the atoms travel, and at the other end of the what are you talking about? Uh, teleporting, yeah. At the other end is where all these streams of atoms are again arranged to the original thing, and so drops out the original
But
thing.
but that's psychologically insane, right? Because see, like imagine you breaking up into smaller pieces and being a puzzle and then getting assembled on the other end of it. Will that person be you if you went through that?
I mean, let's say for
Yeah,
example.
let's bridge
Oh,
one.
this
Let's
like
send Ruchik through, and we'll find out
yeah.
if it's the same. If he's still the
No,
same
no, but
crazy
still,
Ruchik, it's the same
So
one.
no.
but
No, see. I think I know a thought experiment that we can do from long back. I guess I think me and Madhu discussed this long back. Like imagine me and Ruchik are standing opposite to each other. Okay, now we have some kind of apparatus where we can take single atoms from each other. And then Ruchik takes one atom from my body and puts it in his body, and then I do the opposite. Okay. So at what time will Ruchik become Amir and Amir become Ruchik?
When a
Crazy,
majority
right?
of the exchange happens, probably, yeah.
Because,
Crazy.
like, see, even if you change the body, but still, like, consciousness, like, there's one more question of consciousness, right? And then also
True.
there's one more question, okay, Madhu. This makes me go crazy. Our body sheds the old atoms and like the dead cells and everything, right? So like every I think every 2 years, all the cells and atoms in our body they get replenished, correct?
Regenerate.
So Amir right now will this Amir be as same as the Amir that will be in the next 2 years? Like because
No.
I'm changing myself completely, right? Everything that's coming into me is new. So even this is a crazy question that I keep having, and then I don't think anybody has an answer for that until and unless we know what consciousness is. I don't think we'll understand this.
Yeah,
And
that's a big part, yeah.
like I think Neil deGrasse Tyson had a very good point. Does consciousness even exist? That was the question he asked. Okay, this is a simple question. Okay, simple question. But think about the example I gave you guys right now, and think about consciousness. What is consciousness? Like, does it even exist? I mean, consciousness is nothing but like something like soul in religious terms.
Right.
So these are things that you will make you go crazy, and if you are like high enough, then you'll go crazy.
Now you're making me unconscious. You're making me
I think
Okay,
more you
I
start.
got totally off topic. I'm sorry, guys.
That's okay. But yeah, it actually made me unconscious for a bit. I don't know what conscious is right now. So, Madhu, let's get back to Einstein or the wormhole as we call. And could you reiterate once again so that I have one crazy topic for you after this?
Sure. There's a black hole and a white hole. Both are in theory or in idea. Both are opposite faces of the same coin. So black hole and white hole. So the path that connects both of them, the path not structured from any elements but space-time itself. Space and time. Time is also a very huge factor into this. In this, because when you enter into a black hole, right? So you don't know what's happening to that body that has stepped past the event horizon. So you have no clue of what's happening there. And for it, from its perspective, time. From our perspective, time stops for that person. But for you, time will still keep going at the same rate it has for you. But just for us, because it's so, the gravitational force is so huge, time comes almost very close to a standstill for us from our perspective. So the guy who goes in, he just remains as he is. So this is the concept in all these space traveling movies, like in Interstellar, where the guy does not age because he is in proximity of a black hole where time slows down and he does not age. Whereas back on Earth, everyone has been aging at their regular rate because space-time on Earth is pretty uniform compared to where how it was near the black hole. So it's in a way looking into the future. So we, from our present, looking into the future. That is what happens when you try to know what's happening inside a black hole. Now, you step out to the other end, both connected through the Einstein-Rosen bridge. There, things are coming to you from the past to the present. So, past as in these particles or this person has already stepped into the black hole, and he has traveled to the white hole, and now coming out to the viewer here, standing in front of the white hole. So that is time traveling in the reverse order. So in a black hole, when you try to make sense, you're looking into the future, from present to future, and at a white hole, you're looking into the past. So it's mind bending. It's extremely warping of mind. These concepts.
And contrary to
So that's why we always forget how that time is also a very important factor when you speak about space and time, because this funnel connecting both these bodies is made out of, it's the warping of space-time itself. So space behaves completely differently as we know it, and time also does not make sense there to our idea of time that we have here. So yeah.
Wow.
And I think in Interstellar, contrary to what we were talking about, in Interstellar, when he goes into the black hole, he ends up in a different dimension. I think the fifth dimension.
Yeah.
So even that is one different theory than what we were talking about. So like there are multiple theories.
So, guys, as you were saying,
No. One thing. He lands up in the fourth dimension.
No,
So,
no, no. See, fourth dimension is the time, right?
correct.
Like three dimensions are the normal things that we have,
Space.
and then the fourth dimension is what we perceive. And
Right.
since he is able to like change time and all, I mean, look back into the slices of time, that means he is in the fifth dimension, right?
No, he is in the dimension of time as a standalone dimension. So he has access to time. So he
Okay,
can
then
play with
then the
time.
last few moments of that movie, it's
Hmm.
like what I always thought was he is in the fifth dimension, perceiving everything in the fourth dimension, and we as the viewers seeing everything in the third dimension. Correct.
Probably, yeah.
So, but it's the fifth dimension, right? It's not the fourth.
I
We
don't
we
think
as
so.
human
Yeah.
we as human beings we live in four-dimensional world. Correct. We live in a four-dimensional world. Correct. Without
Yeah.
time, nothing will go. Like we can't be anywhere without time.
Right.
So four dimension is already we are present in the four-dimensional place. I mean physical three dimensions and one time
Hmm.
dimension. So this guy ends up in the fifth dimension is what I thought. I
Probably
don't
you
know.
are probably you are right, Amir.
I need to make it, but it's crazy, dude. Like,
Yeah.
thank you guys for ruining such a beautiful movie for me. Let me watch it once again to understand what exactly. And next time when I'm watching, I want you guys to be with me so that you can make me understand. Oh, this is what it is. You know.
see,
So,
if you are a fifth dimensional being or a chick,
uh-huh.
everything you see in our world, you will see it in slices. These are slices of time, literally as slices, bread slices. You've seen
Yeah.
bread like
Right.
that. You can see. Okay, now if you for example now tomorrow you become a fifth dimensional being. Okay, fifth
Okay.
dimension or fourth dimension. Please, like I need to work on this. But
Me.
still, on the other side, you will see every single or the history and the future of the whole universe that we live in. You will have it presented to you in slices. Correct.
No.
Why slices is because you will be able to pick the time you want to go in. You can pinpoint the time. You can just take the slices and slice and view what's happening there, okay, and then put it back again. Then go to the future. It's like a walk for you.
I think that's the one which actually they showed it in Interstellar as well, right?
Yeah. Yes,
Yeah,
yes.
he was actually looking back at time, like he was actually taking back what one
Exactly.
area to
So
go
that's
times.
so for that to happen, that he has to be in the fifth dimension, I guess.
Exactly.
Because if you are in the fourth dimension, you will be a like accessory of time, but not someone who could change time. I think he has to be on the fifth dimension.
Yeah, it
And
makes
then crazy. What's crazy is in the movie he is in the fifth dimension, perceiving everything in the third dimension. I mean, fourth dimension, and then we watching it is in third. No, the people who are filming it are in third dimension, and we watching it is in the second dimension.
Yeah.
It's fun to imagine all this.
So okay, let me get back to the topic which we were in, the wormhole and the white hole. So do you think there will be an alternate universe after that?
A parallel universe. How's
Yeah.
that?
I mean,
yeah.
what is the concept behind it? I mean, what is the entire hype about it? Because let me tell you, recently I saw the series, I mean, the series finale of Dark in Netflix. Believe me, it just blew my mind.
Don't spoil it for anyone, please.
I'm not spoiling it for anyone. Get us ahead. So, all I want to know is, can alternate universe exist?
Yeah,
It's a
that's a
theory
question
again.
that we worked upon, right?
Yeah, it's
And then
hypothetical.
if we have to talk about time travel and paradoxes and like alternate dimensions, I think we'll have to do it in a different episode itself because it will take a long time for that to happen.
Okay, let's
Actually,
give
we can. Yeah.
I
let's
guess
brief about
alternate, parallel, and multiple universes that we can speak. I guess.
I was actually about to say the same thing. So we can actually at least brief them about what exactly is the, since dark is right
I
now,
got
which,
time. I don't have anywhere to go.
because
Yeah.
dark is something which is trending number one in the world right now, and that
Mhm.
series literally blew my mind. Me being a person who's like extremely low IQ when it comes to the science stuff, basically, you can say that. So for me, it was like mind blowing. Of course, for you guys, you will be going to the next level for sure. So we will talk about it again. So before that, yes, Madhu, please, Madhu or Amir, anyone, please explain us.
Amir,
So where to start? Like multiple universe. I mean, I'm still uh, senseless about like multiple universe theory and like and also there's one more thing. I'm not remembering the term for it. Uh, Many world scale. Even this is there, and then parallel universes, different universes, and then just how black holes. Madhu was talking about how black holes can give birth to a different universe, right?
Mhm.
So
Right.
that comes into different genre of the this thing, multiverse basically. Okay, so it's every universe is like a single bubble.
Okay.
So you like even that is there, and then oh god, there are so many things that we can talk about. I'm getting all of this in a single time actually.
huh.
So
So
and then
Noted, yeah, I can understand.
my understanding is uh,
and there's one more thing, like every action that you take, even me shaking this finger, I can like every action that every atom in this world takes, no, our universe get created for that.
What?
Yeah.
All
So
right.
Uh,
Action has an
right
equal.
now, right now, we are talking about this topic, right? There is one more universe where we are not talking about this topic, but we are shooting for the first episode.
All right, Amir. See you tomorrow.
This is even this is very far. Okay, now the places we are sitting, no, even that can be switched. Like I think Ruchik is wearing a hairband right now, right?
Mhm.
Even those minute differences, no, we'll have a different universe for that. Every single step you take, I mean, if you're thinking like even you thinking like doing something, no, it creates a different universe. This is the theory of many worlds, basically many worlds interpretation, and this is shown brilliantly in a series called Devs.
Devs.
oh,
Yeah,
yes, I've heard about it.
you
Okay.
should
I've
watch
not
it.
watched
if
it
you
yet.
if you like dark, you will go
Ah,
crazy about Devs.
okay.
And I think they explain it very well there, actually better than what I can explain. No, you can actually visualize it.
All right. So, ladies and gentlemen, you have it here. Mr. Amir Hussain has just told you. Please, please, please do watch Devs. Even I'll have to watch it now. And let's see how it goes and what it is all about. Madhu, you were explaining us something about same alternate universe theory.
so yeah. The idea is uh, Big Bang for us is the origin of everything that we know.
Right.
The idea of
Right.
time, the idea of space came from that singularity that blew up and made us. So there are these ideas being worked upon right now, wherein this might not be a single event. There might have been numerous Big Bangs in the past, just before our own Big Bang. So each of this forms a new universe wherein the uh, fundamental constants are different.
Yeah,
Like
different a little
in
bit.
this universe, for us, the light speed is rounding it off 3
300,000.
lakh kilometers per second, right? Now, there might be this is a fundamental constant. Nothing can beat this. Nothing can. There can never be a faster thing in the universe, in our universe. Now, in the other universe, this may be different. Probably the speed of light is much quicker, or very slower, or probably just a tiny bit variation. The same thing with the weight or the mass of atomic particles, neutrons, electrons, and protons. So they all of them have a certain amount of charge, a very specific amount of charge, and very specific amount of mass. Now you just change this a bit, we would not be here. The universe that we are living in would not have been the way it is if you make tiny alterations there. So the idea is there are many big bangs, and every big bang is creating a universe of its own, every bubble of universe of its own, with different values for fundamental constants. Okay, this is what's called the anthropic principle. Okay, you have many worlds, many universes with different values. Now there is this one more theory which came out in 1970s, I guess. It is heavily inspired by Charles Darwin's theory of evolution, or natural selection, sorry. Theory of natural selection, biological theory of natural selection, as in how an animal
Can become a human being?
not that, how it gives
Survival of the
how it
fittest,
has
basically.
our offspring of its own to ensure that the offspring is better than the parent, and also while giving it better chances of survival, so that it someday can have its own offspring which can be a better version of the parent. So cyclic, right? So very similarly, it's called the cosmic theory of natural selection by a guy called Simon something. I can't remember, but this is what he said. And again, this is connecting our current topic to black holes again. So he says black holes may be the things that, in a sense, you can say is a parent. So it wants to make better universes in which it is easier for black holes to form. Okay. Now, the idea was that if every black hole that opens up or forms, it is spewing out all the matter and creating a different universe out of all this matter coming out through the Einstein-Rosen bridge, out of the white hole, and creating a new universe. And probably the fundamental constants values may be slightly different, so that in such universes it may be faster for black holes to form, because somehow, as enigmatic as it seems like there is a connection between the existence of the universe and black holes, because every galaxy that we see, there is a massive, supermassive black hole holding the entire galaxy together. So if that was not there, our galaxy would not be the way it is, and our sun would not have been there, and we would not have formed.
Maybe like the black holes in the center of the galaxies. No, maybe they are learning based on what is around them, and then taking those readings and then altering some things about them and creating a different universe on the other side. Basically.
Yeah, true. Because singularity is the place where I don't think we will ever be able to build experiments or labs which can produce energies which can change the values of these constants. Like if you had to make the speed of a photon more or less, the energy of that container or that condition has to be huge, right? So if you need to melt something, you need to provide it energy, right? So the things that we know of uh, require a few 100 degrees of energy, and it changes form and matter. Now, if the energy is insanely high, it is possible to change the values of these constants themselves. So it's happening at the singularity, at the heart of the black hole. And then the new particles that are coming out have different values for those fundamental constants. So possibly we are all just offshoots of black holes trying to make universes so that better black holes can exist. Yeah. So yeah, this is
another level, man.
I am actually in some other world right now.
This is depressing, Madhu. This is depressing. Like I know humanity has a huge ego, but still we always thought we were special, kind of special. Okay, but you telling this made me go depressed like crazy. Like we are just garbage basically.
we don't matter. I mean, if you look at the pictures of Earth,
We just came into existence without without any consequence. We came into existence just by chance.
Fair.
Just by
Guys,
chance.
I need to drop. My battery is now 1%.
Oh, okay.
All right. Well, Atul, thank you so much for joining us today.
Thank you.
It was good having you, man.
Yeah, it was a very nice session. I learned so many things in a day and in few hours or minutes. It's crazy. I'm so happy. Today is a productive Sunday.
Thank you, Atul, for joining us, and
Thanks, Atul.
Please do
and
come back.
your music soon. I hope we'll be listening to your song very, very soon.
I am very, very much excited about it already.
We'll be jamming soon.
Yes.
All right. Well, thank you, Atul. Thanks a lot, and see you next time.
Yeah, thank you so much, guys. Take care, man.
All right. Bye-bye.
You too.
Bye-bye.
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 So yeah, getting back to the topic, let me.
Wait. I'm not done. Okay. Yeah.
So basically, what you're saying is, if every black hole is actually producing a new universe or a new offspring for itself, so some black hole may have produced its offsprings, and we are just the byparts. I mean, we are just the like, what do you call that, the extra. We are just nothing.
Unplanned byproducts. Yeah.
The byproducts, exactly, that's the word I was looking for. So we are just the byproducts for something which happened, so that he can, or they can create their offspring. So we can just, all these planets, these suns, these stars, these are just like, nothing. They're just byproducts, and we are nowhere.
Yeah. Producing a universe wherein it's easier to form black holes also means that it must be easier to form huger stars, because for a star to form, it takes a lot of time, a huge amount of time in human scales. So there's just all this gas and dust.
Yeah,
and now,
which we spoke about last time.
Yeah, the nebulae, they are just expanses of gas and dust spread over thousands of light years. Okay,
Right.
And from them, with the right conditions, like space is cold, right? The minute you go to the let's say you hitch a ride on the International Space Station and step out for a spacewalk, and then decide you just want to get out of your suit. Not that that's possible either, but you do that, you instantly freeze, because space is extremely cold.
Okay.
Now, extremely harsh due to the radiation as well, but the temperature itself is very cold. Now, for these black stars to form in the first place, there must be a tiny amount of temperature. There must be enough heat.
Right.
Not the heat that we see in the kinds of stars, but a few degrees Celsius of heat. And once everything starts clumping together, you also want to ensure that the radiation coming from the other stars are not spoiling this reaction, wherein the gas atoms are forming molecules and clumping together. If you expose it to enough radiation, again they will break apart. So you don't want that also to happen. So you want to have substances that can shield you. So that comes from hydrocarbons, hydrogen, carbon, and water, oxygen again. So and once this has started happening and there's ice crystals forming around it, so it's kind of well jacketed to the exterior forces. And over time, this keeps happening, and then you have the stars, which again over billions of years run out of their fuel and may possibly become black holes. So yeah, all of these are required to just form a black hole. And we also happen to form out of those same stuff: hydrogen, carbon, oxygen. Yeah.
Yes, star stuffs.
Yeah.
We are made of stars.
So this is the another take on it, on the origin of universe. Now the other idea is that if you just have space just sitting there, nothing happening in it, nothing moving across, just still vacuum, still space over, and you just allow that to happen for a very long period in time. It's theorized that string theory says that the micro fluctuations that happen in the median of space can just form a Big Bang just out of nothing. So there are these particles popping in and out of existence all the time, just in vacuum of space. So one matter and antimatter particle, they form, and again they fall into each other and they cancel out each other. So it's not there at all. But you give it, this is happening right now everywhere, mostly in vacuum, right, in the vacuum of space, because right here we have atmospheric pressure, we have the temperature, we have the atmosphere itself and the sunlight, all these disturbing these processes. But out in the voids of the cosmic expanses, interstellar vacuum, there's nothing there. So if you just sit there for billions or probably trillions of years, it is possible for everything that we know to just come out of tiny variations in the cosmic background, and a whole universe pops into existence just out of nothing.
That's crazy.
Extremely.
And let me tell you guys that this is something which is like which will take you off the course and you will start thinking a lot. And so I have already started thinking a lot about all these things. I have so many other topics as well. Like I actually wanted to know really about time loop, the time travel theory, the time travel and the time loop and infinity loop. When it comes to time loop, again the infinity loop, alternate universes. Since I just saw Dark, so I'm still in that mode. So I wanted to know about all these things, and I know that we are very we have a very limited time bound. We have time foundation as well. So what say we'll include this in a different podcast about this, because
I think that will be better. We can talk about it more like instead of briefly, we can like talk about it
exactly
for a longer time. Yeah.
True.
So we can start from alternate universes once again, and then go to time loop, and time travel, and then time loops, and all those things. All in theory. Let me tell you guys, this is nowhere. We don't have proof for most of these things. It's all hypothesis. It's still,
but still mathematically proven. This is all possible. Like how the gravitational waves were just mathematical possibilities, black holes were just mathematical possibilities. The Higgs boson, the stuff that gives mass to things in the universe,
just a possibility once upon a time. Exactly.
Yeah, sure. Let's do this in a different episode and talk more about this.
Exactly. So, well, thank you guys. Thank you for joining us once again, and it was really wonderful once again to talk to you guys about all these things. Unfortunately, Atul had to drop out, but seriously, we had a
He didn't miss a lot, but
Yeah.
we had a good time. I mean, I literally had an amazing time, and I had a lot of learning things to do today. I mean, I learned a lot of things, and it was amazing. It was really good. I hope that our viewers also liked it. And guys, if you have any suggestions, please feel free to drop us a text or message, or you can just comment on the section. And believe me, we read each and every messages and comments which you write there. And please give us suggestions what we have to talk about in the future, what we should talk. And if we missed out on something in this podcast, if you think that we have something, I mean, there was some errors and mistakes, we are really sorry about that. We're just amateurs, we are just starting up things. And if you think that we need to talk more about some things which you think we should, please let us know. And we will try to improve ourselves episode by episode. We can actually do something much better. Well, hope you all enjoyed it, you liked it. And Amir, Madhu, thank you. Thanks so much for joining us. And thank you guys. And please do like, share, and subscribe to our channel, A3R3 Quandary. And next time, we'll see you again in another episode of In and Beyond with A3R3 Quandary. This is Ruchik signing off. Take care. Good night.
Live long and prosper.
bye guys.
Bye.